In this video, we are going to learn the concept of shear stresses. What are shear stresses? Shear stress is the stress that causes shearing of two planes in a given cross section. It is denoted by tau. This symbol is known as tau. Let me illustrate it. Let's assume a beam of the cross section depth d and width b. The profile of the beam is the applied load is V. If we consider this cross section, let's call it section AA. We require to find out shear stress at the section AA. So the shear stress will be acting as I'm drawing. Let's assume we cut the section at AA and split the beam into two parts. Just for explanation, the shear stresses will be acting this way, and on this face it would be like in opposite direction. Means these two planes are trying to slide past each other. That means one plane is this way and it is trying to slide past each other or shear off past each other. The average shear stress will be found out by the ratio of shear force acting at the section, that is obtained by shear force diagram, and the area parallel. For this case it would be shear force divided by B into D, since this was the area parallel to the force. To find shear stress variation within a cross section means we desire to find out how much stress is varying in a cross section. The shear stress profile is constructed. The shear stress profile is second degree curve usually, or we can say it is parabolic. The formula to calculate shear stress profile is tau is equals to VQ over IT. In this formula, we say that V is constant for a cross section. V is the shear force obtained from the shear force diagram we draw for the given beam or any other member. I is the moment of inertia perpendicular to the force axis. For example, let's consider this was my cross section. B was the base width and H is the height, and the force was acting. So I would be BHQ divided by 12. Similarly, T is variable for a cross section, but since it is just a rectangular cross section, so the thickness T is constant. That is, T is equals to the width of cross section. T is basically the thickness of cross section here, and Q is the first moment of area that will be discussed in detail in the example in next videos. Q is basically variable for a cross section. So we get various points of shear stresses by calculating various views and substituting the value in the formula. Note that Q is 0 for these two edges, since there is no area at the edge points. In further videos, we will discuss how to calculate further the first moment of area. Since shear stress is a stress, so the units for shear stress is Newton per meter square or megapascal, KSI, PSI, depends upon the which units you are working in. The important thing to keep in mind while drawing a shear stress profile is, for instance, that let's assume a cross section. In order to draw a shear stress profile, we need to select multiple points on the cross section so that we get multiple values of VQ over IT. At this point, we will get a VQ over IT value. At this point, it will be another VQ over IT value. At this point, another VQ over IT value, and at this point, another VQ over IT value. So we will get multiple points on the diagram, and the shear stress will be plotted using the magnitude of those values. Thank you for watching and subscribe for more. Next video we will discuss the example of calculation of shear stress profile.